Hi, welcome to Hands-On with Force Effect and Force Effect Motion. In this series, we're working to understand the concepts behind crane design. In this part specifically, we'll be continuing our crane analysis in Autodesk Force Effect. Let's go ahead and tap on the boom itself. What we've done here is we're looking directly at the forces being applied to the boom based on the weight we have on the end of the arm. One of the things you'll notice is that we have currently a moment of roughly 106,000 foot-pounds. To put that in perspective, the new 2013 Ford Shelby GT500 Mustang has a supercharged V8 engine and can generate 630 foot-pounds of torque, which is an enormous amount of torque for a car. So you can see kind of relatively what that 106 does for us. That's an awful lot of torque being placed on that beam. But we haven't added any design elements to help add support to this crane. You'll notice in the background image, there's extra cables that provide support. Let's look at how we can move or reduce that torque on that beam. We're going to go back to our Elements menu, and let's sketch in the engine housing in the back here. And it doesn't have to be exact. We just want to get some basic shapes in here so that we can understand how the reaction forces are going to change as we change our design. Now that we have the elements drawn in, we can go ahead and let's weld that joint again to the base. And we're now ready to add in our support cable or our support element. We're going to go back to our elements and tap and drag on the screen to connect the support mechanism on the back of the crane to the end of the boom. We want to do one more thing here. We want to go ahead and convert that joint where the boom meets the base back to a standard joint, because technically that pivots at that location. By doing that, we now are in balance. You can see that in the icon in the upper right-hand corner, which is green. And the calculations are ready to solve. You can see we still have the same reaction forces we had. But now, if we tap on our boom element, you'll notice that the forces are compressing the boom. The other thing we might want to look at is the support wire that we added in, which is under tension. You can see as the arrows pull away from the center of the item, it's under tension. Again, pushing towards the center, you're getting compression. You can see the rear support is under tension as well, which makes sense because as the weight is pulling down, it's stretching or pulling on that rear support. The angled support here is under compression because it's trying to resist that pulling of that weight. The other item we want to look at is where that torque moved to. So while the torque is no longer at the base of the boom, there is still torque being generated, but you'll notice if we select this edge of this engine compartment, the moment being generated now is only roughly 40,000 foot-pounds, as opposed to the 106 we had before, which is greatly reduced and much safer. We still have a problem with the balance, though. What we can do now is let's go ahead and go back to our Forces menu and add a distributed load. Let's zoom in here on our engine housing. Let's go ahead and put a distributed load in here that might represent the engine or a counterweight or something to that effect, the cab that you sit in. And by doing so, we'll just add some force. Right now we have about 12,000 pounds of a distributed load. Let's go ahead and change that to 20,000 pounds, which roughly represents the engine, some counterweights, the cab, and other materials on the rear of the vehicle. By doing this, you'll see now that our reaction forces are much more balanced. We don't have the one on the rear facing down anymore. And this crane, as designed in our crane game, is much more safe and much more stable and should be perfectly acceptable for lifting the loads that are seen in the game. Now that we have a basic grasp of the factors behind crane design, let's try to apply this to a modified version of our old crane. This one features a boom that is 50% larger than the previous version. Open this file in Force Effect and go through the process similar to the one you just saw, paying close attention to two main things. First, the change in forces on the cables, which components are being compressed and which are in tension. How much more or less tension or compression are these under? Could this be a problem? Would more cables be needed? And second, pay attention to the reaction forces to ensure that the crane doesn't tip over. What are at least two ways to reduce the crane's likelihood of tipping?